Hey everyone, I'm MJ and welcome to Eugene Math Mentor. We're going to discuss set theory. In mathematics, a set is a well-defined collection of objects called elements. Take note that the order and multiplicity of the elements are ignored. Examples of a set are the set of letters in UP1 and the set of numbers from 1 to 5. If a set has a definite number of elements, then it's called a finite set. Otherwise, it's called an infinite set. For example, the set of letters in UP1 is a finite set, and the set of whole number is an infinite set. There are various ways to represent a set. The first one is the statement or rule method. In this method, the elements of the set are being described. For example, x such that x is a letter in UP1. Second is tabular or roster method. The elements of the set here are being listed. For example, the set containing U, P, O, N, E. Last is the set builder method. The set is given with the mathematical rule. For example, x such that x is an element of integers and x is greater than or equal to 1 but is less than or equal to 5. Let's move on with the list of set notations or symbols. Take note the sets are denoted by uppercase letters and its elements are denoted by lowercase letters. Okay, so we got A is an element of A is not an element of A, cardinality of set A, or simply the number of elements in set A. Null or empty set, these are sets with cardinality equal to 0, or these are sets with no elements. We got universal set. This is the set consisting all the elements under the context. A is equal to B if they have the same elements. A is equivalent to B if they have the same number of elements. For example, if we have set A containing 1, 2, and 3, and set B containing 4, 5, and 6, then these two sets are equivalent because they both have the same number of elements, which is 3. Finally, we got A is a subset of B, which means all the elements of A exist also on B. A is an improper subset if it's a null set or if it's equal to B. Otherwise, it's a proper subset. Also take note, if we have set A with cardinality equal to n or set A containing n elements, then it has 2 raised to n subsets. A Venn diagram is a pictorial way of representing sets. As you can see in the figure, there's set A and set B inside the universal set. Now, let's talk about set operations. First is the union of sets. In this case, we combine the elements of the sets involved. For example, if set A contains 1, 2, and 3, and set B contains 3, 4, and 5, then A union B is the set containing 1, 2, 3, 4, and 5. For the intersection of sets, we take the common elements of the sets involved. Using the same example, A intersection B is the set containing 3. For the difference of sets, we take the elements of the first one that are not on the second one. Again, using the same example, A minus B is the set containing 1 and 2. Finally, the complement of a set contains all the elements not in the set but are part of the universal set. Letting the universal set be the integers from 1 to 10, the complement of A is the set containing the integers from 4 to 10. Let's take note of some theorems and properties on set operations. If the intersection of two sets is null, then they are disjoint sets. Like in number operations, the union and intersection of sets are commutative, meaning Reversing the order of sets yields the same result. There's also the associative property. If you're taking the union or intersection of 3 or more sets, it doesn't matter which pair you work on first. For the distributive property, you can distribute union over intersection. That is, A union quantity B intersection C is equal to quantity A union B intersection quantity A union C, and vice versa. To get the complement of the union or intersection of two sets, we get the complement of individual sets and change the operation from union to intersection or intersection to union. This is actually called the De Morgan's law. The cardinality of A union B is equal to the sum of their individual cardinality minus the cardinality of their intersection. And the cardinality of A complement is the difference of the cardinality of the universal set and A. Now, let's apply this into practice. Which of the following represents the diagram? You can pause the video from here and try to answer the problem. Did you answer letter A? That is correct. But, is it the best answer? The best answer here is letter D. Don't be upset, okay? Let's examine choice A. What you can see right now is B union C. If we take the complement of that, it will be like this. Now, if we take the intersection of that with A, then it will be like this, which is the diagram earlier. But it doesn't end there. We can apply De Morgan's law on the complement of B union C. Then it will become B complement intersection C complement. Now, we have the intersection of three sets. And we can apply the associative property and reapply De Morgan's law as you can see here. Okay, another one. Among the 40 students, 32 like math, 16 like science, and 8 like both. How many of them don't like any? So pause from here and answer. Did you answer letter A? Then that is correct. But, just kidding, that's it. So if we let M as the set of students who like math and S for science, we can represent them as follows. Cardinality of M is 32, cardinality of S is 16, and the cardinality of the intersection is 8. Now, remember the theorem earlier, N of M union S is equal to N of M plus N of S minus N of M intersection S. So that will be 32 plus 16 minus 8, and that's 40. Also, N of M union S complement is equal to N of U, which is the universal set, minus N of M union S. So substituting the values, we'll get 40 minus 40, and that is equal to 0. Well, that's it about set theory. Set theory is actually a very important prerequisite for algebra, statistics, and probability. So I hope you learned a lot today. Thank you for listening, and don't forget to follow my page or Eugene Math Mentor for more math videos.